Good morning, everyone. Thank you for joining us here live today and those watching live streamed. How's everyone's Ignite going? Last day? Hope you guys all had a great one. Today we're going to talk about helping you get from pilot to production the quick, easy, and optimized way. How many are piloting generative AI today? And how many are already in production with your applications? Okay. I am Charlie Huang. I'm a senior product marketing manager in the enterprise AI group at NVIDIA. I lead the go-to-market with our CSPs for our enterprise AI solutions. With me are my two colleagues.
Hello, my name is Abhishek Savarkar. I am product manager in the NVIDIA AI enterprise team, and so happy to be here talking to everyone and displaying our work. And we have Vineet.
Hey everyone, hi, my name is Vineet. I'm a senior solutions architect at NVIDIA. I've been working with Charlie and Abhishek for the last year in integrating some of our NVIDIA software onto Azure. So here to show you what all we have and what you can do to take your GenAI applications in production on Azure with NVIDIA software solutions. Nice to meet you all.
And so here's what we have planned for today. I'll just go through a quick partnership overview of how we partner together with Microsoft and Azure. Give a general landscape of the generative AI market as it is today and going forward. And then Abhishek will cover our NVIDIA AI Enterprise and NIM solutions in a little more detail. And Vineet will wrap that up with a demo. Microsoft and NVIDIA has had a long-standing partnership. You can see on the left, it started out with, I think, most are familiar with our GPUs, but it really has evolved past that, where it starts at the infrastructure level, where you get the acceleration for your applications. But then there's integrations into, we have DGX Cloud, which is one of the two CSPs that DGX Cloud is currently available on now. Omniverse Cloud is Azure's the only CSP where Omniverse Cloud is currently available. NVIDIA AI Enterprise, which we'll go into a little more detail, as well as NIM. There's integrations within various Azure services as well, as you can see in the middle column, and then a bunch of ecosystem partners that we share jointly with Azure that really make our joint solutions come to life. Here's the NVIDIA Accelerated AI Infrastructure Platform. So I think what you're familiar with, again, is the layer on the bottom, our GPUs that span many generations. And these are the fastest accelerators that you could get on the market today. But it's not just the GPU. It's a full system that you can see. And Azure was one of the first to announce that they've powered on our Grace Blackwell chip in their data center. And it doesn't stop there, because there's a whole software and application layer above it as well. So AI is a full stack solution that you need to consider when you're developing and deploying your generative AI applications. So where are we today in the generative AI journey? Earlier, I think many are the explosion happened. I think everyone's already experimented with ChatGPT. That really caused the explosion. It was kind of the iPhone moment, if you will. And last year, really, a lot of people were experimenting with generative AI, kind of starting their pilots. That kind of bled into this year. And really, now organizations are trying to figure out, OK, I've piloted this, but really, how do I get into production? And there are various stats out there that say only maybe 30 to 50% actually successfully make it into production. And this is why we want to come here today to share with you how can we help get you from pilot to production. Here, maybe many of you are doing some of these use cases that you see on the screen here, whether it's a Copilot, something to generate content for you if you're in sales and marketing, or chatbots helping you with customer service, improving customer satisfaction. These are just a few examples of where we're seeing a lot of the generative AI applications being built for. So I want to hand it over to Abhishek now to go into some of the solution details that we offer together with Azure.
Thank you, Charlie. All right, so we can go ahead, get started about NVIDIA AI Enterprise and NIMS on Azure. NVIDIA as a platform, everyone knows it's a chip company. It started out as GPU manufacturing company, but then we have expanded our portfolio to other hardware, and not just hardware, the entire tech stack with application frameworks as well. So along with GPUs, we have CPUs and DPUs, but on top of it, we have software platform. And three pillars of NVIDIA software platform are HPC, NVIDIA AI Enterprise, and Omniverse. On top of that, we have applications and frameworks that help our developers and users to build applications that are GPU accelerated and get the best boost on top of NVIDIA GPUs. So today in this session, I'll talk a bit about NVIDIA AI Enterprise and the star product within NVIDIA Enterprise, which is NIMS and NeMo. All right, a high-level slide on what NVIDIA AI Enterprise is. In short, it's production-grade software for AI. It has three pillars. We have runtimes, which includes SDKs, libraries, toolkits, and microservices that can quickly get you started. Today, we'll talk a bit about generative AI runtime called NIM. But along with that, we have a bunch of other SDKs, toolkits included within NVIDIA AI Enterprise. It is enterprise-grade software, so we guarantee security, stability, and support for this software. There is defined SLA with this support. We secure the software with CVE patching on regular cadence and all the enterprise goodies that the companies care about. And we design the software in a way that is cloud-native and deployable. You can pick and choose whatever Azure services or Microsoft services you want to deploy the software on. It could be Azure VM Compute, it could be Windows machines, or it could be on the edge as well. So let's dive deep into the generative AI runtime. Before that, basically on a high level, right, a lot of customers and developers start out with inference today. They test out generative AI models. They test out the responses, the performance of these models. Right? We all go to ChatGPT and check out, right, how the response is for our random queries. A lot of enterprise then realize that the models perform well on generic or general queries, but not so much on their proprietary data. So in that scenario, they then go to the next step, which is training and customization. That's where they have their proprietary data, and they customize the model to respond well on their proprietary data. Right? Once the model is customized, they deploy it to get responses on their proprietary data. But then over time, right, as data changes, the model's responses might not be that accurate. So that's where, again, it's a loop where they have to prep the data, get the feedback from the users, prep the data, train and customize, and deploy. We all know this MLOps, GenAI Ops, overall flywheel, right? NVIDIA has a few solutions that fit into this flywheel. We have NVIDIA NeMo that has curator, customizer, evaluator, and retriever type of microservices that handle all the data prep and training and customization workflow. And then we have NIM. NIM stands for NVIDIA Inference Microservice. I'm going to say that for the last time here because Charlie has advised me not to expand on that. We just call it NIM. Right? And NIM is highly focused on inference and giving you the best performance in terms of deployment of the model. So NVIDIA has the full stack solution, full stack acceleration, right from data prep to deployment on top of NVIDIA GPUs. So few challenges that enterprises face, right, while experimenting generative AI. As mentioned before, right, a lot of enterprises start their journey by testing out hosted API endpoint services, which are mentioned on the left side. These are managed generative AI services, which are great and easy to use, right, just to get started realizing what the model responses are. But there are certain challenges using hosted or managed AI services, like data privacy, right, mainly shared by a lot of challenges shared by enterprises in terms of sending data over network to these hosted API endpoints, and limited control overall in terms of managing the model, in terms of managing the infrastructure as well. On the right-hand side, we have open source deployments. A lot of enterprises are experimenting it with today. We have state-of-the-art open source models like Llama and Mistral, right, that enterprises are experimenting within their own VPCs, right? So in this manner, they can run and manage wherever they want, on whichever services they want, and they can manage the entire security for that deployment. Also, just to mention, it's not mutually exclusive. We have seen a lot of enterprises use both approaches. A lot of enterprises are using managed hosted API services for big LLMs, whereas SLMs and medium-scale language models are being deployed on their own preferred infrastructure. So in the second case, where the enterprises are quite interested in deploying and managing the model deployment on their infrastructure, we have a solution called NIM. NIM is an accelerated runtime for generative AI models. It's a pre-built container with an optimized runtime packaged in it. It is based on industry standard APIs. We have defaulted to OpenAI APIs, right? So it's easy to use. Everyone knows how to use it, and you can get started quickly. We are supporting community models. I'll get to that in the next slide. But there is a support for not just LLMs, but other generative AI models, which could be vertical specific or which could be domain specific, right? And we have optimized engines. NVIDIA is a performance optimization company. We care a lot about accelerated infrastructure and accelerating the workloads. So we have optimized inference engines for these models. I will dive that into later. So all in all, 3 value propositions for NIMs, which is it is easy to deploy. It gives you the best latency and throughput out of the box, and it has consistent APIs across modalities. So you can pick and choose whatever model you deploy, and it's just 3 lines of code that you have to change to select a new model. All right. So this is one of my favorite slides. It just showcases the breadth of NIM support. We support not just LLMs, which are text-to-text language specific, but vertical specific models as well. Speech domains, we have high throughput, low latency models as NIMs for speech applications. And we'll see a live demo at the end as well, with Vineet has worked on, where we care a lot about end-to-end latency, right? Other than that, we have computer vision models, we have simulation models, we have, of course, LLMs and vision models, and RAG-specific models like retriever, embedding, and re-ranking models. And down below, you can see we are working with all the popular model providers out there to NIMify their models and have an optimized runtime, right, for running these models on top of NVIDIA GPUs. You can get started quickly on this. We have a website called ai.nvidia.com. This is where you can learn more about what NIM is, and you can experiment as well on that website. So that website will take you to build.nvidia.com, which is a developer-centric website. We have hosted API endpoints as shown on the left-hand side. These hosted API endpoints are running on NVIDIA Compute, but only for developer experience. So you can get a feeling for how the model responses, what is the latency throughput of the model hosted here, and the simple API interface that you can use to hit the model, get a response, and start prototyping your application. But the call to action is on the right-hand side, which is once you have seen the model performance, go ahead and download the NIM. Download the NIM, download the container, download the model artifacts which are optimized to run on NVIDIA GPUs, and deploy on your favorite Microsoft service. Right? You can deploy on your Kubernetes service or Azure ML or wherever you want. This gives you the best performance out of the box on top of NVIDIA GPUs. So customers or enterprises who care a lot about deploying it in their infrastructure and their VPC will find this very useful to deploy. Awesome. So what NIMs are available today, we have 100+ preview APIs across different modalities, right, on build.nvidia.com, and 30+ downloadable NIMs. We are bridging this gap quickly. Optimizing each individual model and architecture takes some time, but we are working hard to support all the model providers out there and the models of those model providers on NVIDIA GPUs as NIMs. So popular models like Llama 3.1, Mistral, embedding models are available as downloadable NIMs on build.nvidia.com. So you can get started right away. The question is, who is this NIM for? Who is the target persona? Essentially, we have 2 target personas. One is application developer, They care a lot about self-managed deployments and getting APIs which are easy to use and easy to replace when they want to upgrade the model, for example. Right? Every other day we have a new state-of-the-art model coming up, right? So these developers want the best model out there, so easy to change APIs, right? They want to leverage open source models, foundation models for deploying within their own infrastructure. They care about scaling as well as the application and the workload scales. They care about scaling the model on, say, Kubernetes deployment and running on the best available GPUs out there, right? And not just depending on hosted API endpoints. The second target persona is IT DevOps persona, where they care about loosely connected microservices. So NIM stands for NVIDIA Inference Microservice. It's a packaged application that can be deployed in a microservices architecture. It can be scaled individually as needed, right, as the system loads up. It supports standard APIs and also enterprise goodies as mentioned before, right, which is standard support, SLA, and CVE patching with it. All in all, it results in lower total cost of ownership, lower TCO, right, when it comes to deploying the generative AI models on NVIDIA GPUs. And we all know NVIDIA GPUs are so costly, so getting the best bang for your buck is essential. So diving deep into what NIM is and its architecture a little bit, each NIM is model specific. There are two components. One is the container, and the other one is the optimized model artifact. There is a TRT LLM engine, if you guys know TensorRT LLM. It's one of the open source libraries, quite popular out there for optimizing Gen AI models and machine learning models. So NIM comprises of a container and a specific optimized model artifact. The container essentially is the same across most of the models of the same modality. So 80% of the container is same across LLM NIMs. But there is a model-specific layer within the container which is fine-tuned for that specific model to run in the optimum manner. So all in all, you deploy a container, it pulls an optimized model engine to run on top of NVIDIA GPUs, and it spins up the OpenAI endpoints. You can get started in under 5 minutes, literally. If you want to know more about what's inside, what's packaged as a NIM within this base container, we use a fast API server under the hood, which exposes OpenAI endpoints. We have a layer called LLM executor that selects an appropriate runtime, right, based on the NVIDIA GPUs that you are running it on. So it leverages either TensorRT LLM or VLLM under the hood, exposes the OpenAI endpoint, and you can interface with it as you do with OpenAI hosted models. And bunch of API routes that you can leverage for, say, metric collection and scaling, which are cloud native, and you can deploy it, at scale as well. So a high-level overview about what optimizations we do. Basically, two types of optimizations are built into NIMs. Within the container, we have an optimized runtime, which takes care of batching the incoming requests. So in-flight batching is one of the prominent features. And at the model level, we do layer fusion and removal of activations which are not needed, right, at a technical level. So all in all, we do look at GPU architecture, right, what type of GPU you are going to run it on, the number of GPUs available on the compute instance, the profile that you select, either throughput optimized or latency optimized, and the precision, right, one of the most important, keeping the accuracy same and reducing the precision results in much better performance in terms of throughput and latency. And we strive hard to have these optimized engines for a model. So for example, Llama 3.8b Instruct model has a bunch of these optimized model engines, which are mentioned on the right, for specific NVIDIA GPU SKU. And all of these are figured out by the container itself when you deploy it on the specific compute. Same case for Llama 70b, for example, because it's a big model, it won't fit on 1 or 2 GPUs, right? So all of this is figured out by the container itself. You don't have to sit and configure the deployment parameters yourselves. It's easy to deploy and easy to get started quickly. Awesome. So a lot about NIMs. NIMs are individual model specific, each individual model, but then a single model is good, but a blueprint is much better. So we have NVIDIA blueprints, which are reference applications that string together multiple NIMs and have a use case specific reference application. So we have a bunch of blueprints published out on the same build.nvidia.com. You can check it out today. These are use case specific applications and reference applications where we have provided a sample code, sample data to get you started quickly on top of NVIDIA GPUs. And there are tools available to tweak the blueprints as you wish. So these are not ready to deploy applications. These are reference applications that you can piecemeal and choose components within it as you wish for your own deployments. One of the examples is multimodal PDF extraction. This is a reference architecture and sample application that we have upon GitHub as well. This leverages NIMs under the hood. So if you can see the green boxes, these are NIMs that are being leveraged within this reference application, which essentially does multimodal PDF extraction. So you put in PDF files, it extracts text, tables, images, and then you can put it in a RAG workflow to do Q&A on top of it. So reference application available on GitHub, you can get started on it quickly. All right, that was the first part of NVIDIA Enterprise, which is the generative AI runtime. Just a high-level overview about enterprise-grade security. Within NVAIE or NVIDIA Enterprise, we basically have two branches of the software, right? Top of the tree feature branch and a production branch. The feature branch, because the pace of this industry is moving so quickly, we upgrade the feature branch on a monthly cadence, right? And it's a fast-moving feature branch. But a lot of enterprise customers want stability, right? That's where production branch comes into picture, which is stable for a period of 9 months. And there is an overlap where you can upgrade to the next production branch, right? Whenever the next branch is available for your use case. So over a year's time, we have 2 production branches which are stable, which guarantee you API stability, no breakage of the APIs, but we also patch the branch for CVEs, if any, right? Making sure that the best is available within the production branch. Is that your song, Vineet? All right. The third component, just a high level, we have designed the NIM in such a way, and all the NVIDIA software for that matter, right? That can run on any of your favorite services on top of Microsoft. Azure VMs, you can use any of the NC series, NV series, ND series VMs available on Azure. Few of the NIMs, if compatible to run on Windows machines, right, given the memory constraints, can run on Windows. And you can deploy it on Edge as well for Edge use cases. So it's portable, you can run it wherever you want. You can have a hybrid scenario as well. So just to reiterate, all of these goodies are included within NVIDIA AI Enterprise. Again, it's like a production grade software for AI. And there is added support as well, and you can reach out to NVIDIA if there are any issues, right, with when you're running this software on your preferred platform. All right, and in context of Azure, as mentioned before, right, you can run it on AI Studio or Azure ML. Now AI Studio has been rebranded to AI Foundry. You can, of course, run it on Azure VMs, and you can run it on AKS as well and scale the workload as needed. Now, I think enough about talking. We have an awesome demo that Vineet has worked on. Let's see whether we can do a live demo. Otherwise, we have a recording as well. Over to you, Vineet.
Hello, everyone. Hi. The demo was not a Telugu song from India. So, can we share this screen? My laptop? Is it getting shared? I don't see it yet.
No, it's not. I think you have to select.
Can you share this laptop, please? 3. Okay. This is my first time presenting, so I was not aware how to switch. Okay, here you see a bunch of windows here, right? So let me show the demo first, and then we'll talk about what the demo is about, right? So ever since I've come to the conference, I've been mostly famished. I've been almost hungry all the time. So I was wondering, Abhishek, we'll get something to eat.
Yeah, I'm in mood for pizza.
You're in mood for pizza? guess what? The demo also can only order a pizza. So let's show a demo of how to order a pizza by using a pizza kind of like order taking bot, right? So I'm spinning up the demo now. So we have chosen a Twilio number to kind of like create a custom audio bot for this, for the purpose of the demo. So I'm calling to that number. Okay, can you play the audio from my mobile? When I want it, it's not playing. Okay. Can I do it again? I can't hear it out. I am playing it. I'll try one more time. Okay, I'm playing it. Is it coming?
Maybe hold it.
Maybe hold it to the microphone.
Sounds good. Okay, no problem. Yeah. So.
Yeah, put it on.
Have a trial account. You can remove this
So
message
we are
at
using
any
a Twilio
time
trial
by
account, so that's what it
upgrading to a
says.
full account. Press any key to exit. Welcome to our pizza ordering service.
Hello.
Welcome to Pizza Palace. I'd be happy to help you place an order. What size would you like your pizza to be? We offer small, medium, or large pies.
I want a large pizza.
A large pie it is. Now, let's talk toppings. What kind of toppings would you like on your large pizza? We've got cheese, pepperoni, mushrooms, onions, sausage, olives, and bell peppers available. Which ones would you like?
I like mushrooms, onions, and olives.
So we've got mushrooms, onions, and olives on that large pie so far. What kind of crust would you prefer? We offer thin crusts that are crispy on bottom, but soft in center, or regular crusts that are just right. Not too thick, not too thin, or thick crusted pies that are loaded up with extra doughy goodness, or stuffed crusted pies that have cheese inside their crust too.
I'll take a stuffed crust.
Great. I processed your order for a large pizza with mushrooms, onions, olives, and stuffed crust. Have a great day.
Thank you. So yeah, that's the demo. We aren't getting a pizza here today, but we are here to show like how the low latency of NIMs can help you build applications like this, right? So we were able to build this demo by deploying 3 different NIMs, right? The window at the bottom shows what NIMs were used. To the left, we have a NIM, which is the speech to text NIM. It's called the fast pitch hi-fi GAN Riva. So this model converts the incoming speech from the caller to text, and this text is later sent to the second NIM, which is an LLM NIM. Here we have used Llama 3.1 8B instruct model. So we have written a system prompt for the model to like behave like an pizza taking order bot, and we have given it instructions as to what kind of questions you need to ask. So it's able to generate the conversation, which is then later sent to the third NIM, which is the parakeet NIM. This NIM converts the speech, the text back to speech, and the speech is streamed back to the user through the Twilio server, right? So when we were having the conversation, you probably did not notice that there were 3 different NIMs, right, interacting with each other to have this conversation with us. So that's what we mean by reducing the latency of your production GenAI applications. It's smooth for the end user to interact with, and all these NIMs can be plugged together to build a larger application like this. It doesn't always have to be a RAG or an LLM chatbot. You can do stuff like this as well. So we were able to achieve that by deploying all of this on a H100 node on Azure. You can go get it yourself for your infrastructure today. So we have deployed the LLM across 4 different GPUs, and the Parakeet and the TTS and the ASR, both of those models across H100 each. So we have still 2 more GPUs left, which I'm wondering what to do with in this node. But yeah, so we have deployed this on this virtual machine, and you can see how seamless the entire interaction was. Now what you can do is you can put this on like some kind of a container scaling service, like an Azure container service, and then scale it for each of your user, right? We offer opportunities for you to like find different latency profiles, so that if you want to squeeze 2 NIMs within the same GPU, you can still go ahead and do that, right? But how do you like know what models are available, right? So to know that, you can just go to build.nvidia.com. You don't have to know the model name itself. You can just type the task that you're interested in. So you say like speech recognition, right? And the website gives you suggestions as to what models you can try out, and you can try out then and there. For example, I use Parakeet right now. I can just play with this and see if it's of my interest. And once I know it is of my interest, you can just go try the API or download the Docker and then play with it. So if you're wondering how the script itself looks like it's dead simple. So here you can see I'm just exporting an NGC API key, which you would get once you get access to our license. And then it's simple Docker command. You can see I'm specifying the name of the container, a couple of like arguments on like the port and everything, and then you specify the container itself. That's about it. It pulls the container from NVIDIA GPU Cloud, which is NGC, and then you can start using it in your Azure VM. It's basically just a deployment of a container, right? So if you also would like to see this in action, like what does the speed difference look like, then we have an interesting demo to show like how it would look if you deploy the LLM models with NIM and without NIM, right? So here to the left, I have LLM 3.1 Nemotron model, which is right now the best model, like almost SOTA equivalent accuracy. As you can see on Hugging Face, we specify that it is as close to GPT-4 on Claude 3.5, but it's a 7 TB model. So you can deploy this in your own infrastructure, like take like an A100 or H100 node and you can deploy it. And to the left, we have deployed it with an open source inference stack. To the right, we have deployed it with NIM, right? And you go and interact with this model. I'm just asking like, what's up? And I'm sending a message. You can see to the right, the NIM on is able to generate tokens at a faster speed, and it has already completed the response while the NIM off is still generating the tokens. And you can see here we have received around 215 tokens at 4.49 seconds, here 268 tokens at 14 seconds, right? So the performance gain is 2.5 times. So this particular model, the 70MB model, was deployed on NC48 ads instance, or I think it's ADS, nobody calls it ads, I call it ads. But it's a 2x800 PCIe instance optimized with TRT LLM underneath, so you're getting the best in class performance on your favorite Azure SKU, right? All you have to do is just download the NIM container as a Docker container and deploy it. So these two demos hopefully gave you an idea as to what the NIM offering is and what we are trying to achieve with NVIDIA AI Enterprise in general. That's about it. If you are interested in knowing more about how to deploy this on your infrastructure, we have this repository called NIM Deploy. In this NIM Deploy repository, if you go to cloud service providers and in Azure, you see we have various scripts for you to deploy these on Kubernetes service, Azure ML, Prompt Flow, pick your service. We'll be soon adding more instructions to deploy it in other places as well. Not just NIMs, we'll also do for other NVIDIA AI services like Guardrails and Curator and so on that's coming up soon. So yeah, that's it from my side.
All right, we'll hand over to Charlie.
So I'll invite Charlie to give the closing notes.
Can we switch over to the other
Yes, let me go to
presentation?
main. Okay, I figured this out. Nice. Okay.
Not this one.
Should I?
Okay. So Vineet, how long did that take you to build the application?
It's I just had to run 3 Docker commands and secure the right VM SKU. That's about it. It's mostly I spent the time on building the Twilio server, not for deploying the NIMs.
Yeah. So, our session, the quick, easy, and optimized way, right? Look at how quickly Vineet took essentially 3 NIM or 3 models, like community models, and built a whole pizza like ordering application so quickly. And so that's kind of like the easy way is you could see how all of this is run on Azure. So what you're familiar with, the instances, the services, like either you're running AKS or Azure ML or VMIs, you could do it whatever way you're looking to develop and deploy. We're supported on that and certified. And then the optimized way is the NIM. We've optimized, we've done the work for you. So we've containerized these foundation models so that they're optimized to run as quickly as possible, as performant as possible, the highest throughput on the NVIDIA GPUs that you're investing in. So to go on with your AI journey, again, whether you're kind of in the beginning of the journey or you're really trying to deploy your application, or maybe you've already deployed into production and you want to scale, we're here for you to help you accomplish what you want to do. So I think next up, I think you all got scanned when you came in the door. Come visit the booth if you haven't been to the hub. Come check out some of the additional demos. We'll be there as well. If you want to get started right away, if you just want to play around, we have this thing called NVIDIA Launchpad where we have hands-on labs, and we step you through some of these different workflows so you could try out the technology. There's some generative AI examples that I think Vineet and Abhishek posted on GitHub, so you could check those out. The QR code goes to build.nvidia.com/Microsoft-Azure. That just lets us know that we presented to you and we talked to you here at Ignite. And then if you're ready to learn more about the enterprise software, we're in the marketplace, so NVIDIA AI Enterprise, and NIM kind of rolls under this NVIDIA AI Enterprise software platform that Abhishek talked about. That's right there in the marketplace, and there's a 90-day license that you can request as well. We have a little bit of time left, so thank you. We'll take Q&A from the room. I didn't see any online for those that are streaming live, but if you have a question, feel free to come up to the mic.
All right, thank you.
Great. Thanks for stopping by. Enjoy the rest of the conference. Come by our booth if you get the chance. We'd love to talk to you. Thanks so much.
Thank you all.